All right, welcome to the Explainer. Today, we're diving into a problem that quietly costs us billions in repairs and puts public safety at risk every single day. We're talking about the silent destruction of our roads and bridges by overweight vehicles. And we're going to break down how a new wave of AI and edge computing is creating, well, an automated guardian to protect our most critical infrastructure.
And that right there, that's the heart of the issue, isn't it? This isn't about one big, dramatic bridge collapse. No, it's a constant, hidden stress. It's a slow creep. Every single day, trucks that are too heavy or too big are causing this cumulative damage, the kind we only find out about when it's way too late and incredibly expensive to fix.
So for decades, our whole approach to managing these oversized and overweight vehicles, you'll hear them called OSOW, it's basically been based on paperwork, permits, and, the occasional roadside check. But let's be real, in the face of modern logistics, this old reactive system is like trying to catch rain in a thimble. It just doesn't work. It's time for a major shift, from reacting to damage to actually proactively preventing it.
And this slide just lays it out perfectly. On the left, you've got the old way. You issue a permit and basically hope for the best. Damage is something you deal with later. But on the right, the AI-driven model completely flips the script. It's all about predicting stress before it can even happen, intelligently guiding a vehicle's route, and enforcing the rules automatically, right then and there, in real time.
Now this is a really crucial point. The goal of this tech isn't to throw up a bunch of roadblocks and grind the economy to a halt. It's actually the exact opposite. It's about creating a smarter, safer system that protects the stuff we all own together, our roads, our bridges, while making sure that legitimate business can flow as smoothly and efficiently as possible. So how does this AI Guardian actually work under the hood? Let's get into the technical blueprint and really trace the journey of a piece of data, all the way from the highway pavement to a fully automated decision.
Okay, so it all starts at the edge, and by that I mean right there on the side of the highway. Step 1, a whole bunch of sensors. Think weigh-in motion pads and smart cameras. They grab the raw data from a truck as it passes. Then, step 2, small, powerful computers right on site process that data instantly. This isn't getting beamed up to a distant cloud. It's happening in a split second. And then step 3, that fresh data gets fed into a risk engine, where machine learning models figure out the potential stress on the bridges and roads just up ahead.
And this is what that output from the edge looks like. It's basically a clean digital fingerprint of the vehicle. You can see its license plate, the number of axles, and here's the kicker: the system's estimated weight versus what its permit actually allows. And you can see the system is 92% sure about its numbers. This clean, structured data, well, that's the fuel for the whole system.
So with this data in hand, the system has to answer a really important question. It's not just, hey, is this truck overweight? No, it's much deeper. It's, if this specific vehicle keeps going on this specific path, what is the precise risk it poses to the infrastructure ahead? And answering that, well, that requires the next layer of intelligence.
So let's move to the brain of the operation. In step 4, a generative AI engine takes everything: the truck's weight, its route, the risk score, the legal policies, and it makes a holistic judgment. Step 5 is the action. That decision automatically triggers some kind of enforcement, maybe an alert to the driver or even a physical barrier. And finally, step 6 is crucial. The system learns from every single event, so it gets smarter and more accurate over time.
Okay, now we're getting to the really interesting part. This is where we go beyond just measuring stuff and into the world of complex reasoning. We're talking about the Gen AI decision core.
You see, this is the key role for Gen AI here. It's not actually weighing the truck. Other sensors are doing that heavy lifting. Its job is to be the synthesizer. It takes in these 4 totally different kinds of information. You've got real-time physics, structural engineering risk, bureaucratic permit data, and legal policy. And it has to reason across all of them to come up with one single coherent decision.
So how on earth do you get an AI to do that? Well, you give it a job description. This is pretty much the prompt that engineers use. They're telling the AI, your job is to act like an expert OSOW safety agent. Here's all the info you need to consider. Now, make the call. This is how you turn a general AI into a super specialized expert.
And here is the result. The Gen AI doesn't just spit out a yes or no. It gives you a structured decision contract. The decision is crystal clear: reroute. The reason is specific: bridge under stress. It even gives a solution: take the alternative route. And this is so important because it means it's not a black box. The decision is explainable, you can audit it, and it's ready for another automated system to act on it immediately.
Okay, this all sounds incredibly ambitious, right? So how do you actually get started? Well, you don't try to boil the ocean. From a software development point of view, you build what's called a minimum viable product, an MVP, to prove that the core idea actually works in the real world.
So, a really smart MVP plan would look something like this. You start small, you target just one high-traffic freight corridor. You limit the tech you're using to just the essentials, sensors for weight and for IDing the vehicle. And you focus on one single high-value job, automatically catching trucks where their actual weight doesn't match their permit. You prove that works, and then you can scale up from there.
And that really brings us back full circle to this fundamental shift in thinking. We have to stop thinking about safety as a few scattered checkpoints on a map. The future of protecting our infrastructure is a dynamic, always-on system of risk management that lives right where the action is, at the edge.
So if you take one thing away from all of this, let it be this. The sensors and the machine learning models, they do the measuring. The Gen AI, it does the deciding. It pulls together all this complex, sometimes conflicting data to figure out what needs to happen next, and it makes that call before our infrastructure pays the price. And that right there is how we can finally start getting ahead of the problem and protect the roads and bridges we all depend on.